Welcome to the second day of section 7.2. Again, we're going to be calculating area bound between two functions, or the area between two curves. Today we're going to do something a little bit different, which is integrating with respect to y. So instead of having a bunch of x's in your equations, you're going to have a bunch of y's and integrate with respect to y. That means that your lower limit of integration and upper limit of integration also have to be y values. So you have to always keep in mind that you're looking at the y values. And the one thing that's different, remember we took the top function, subtracted the lower function. Now we're going with the right function minus the left function. Those are the big differences between this type of integration. So let's take a look at problem number 22 on page 395, finding the area bound between these two curves. And let me graph that. Okay, so I graphed these two functions. The first one, x equals y squared, is a sideways parabola. And the second one, x equals y plus 2, is a line. All right, now this is easily integrated, and the area between these two curves, if you go from right to left and take the line minus the parabola, sideways parabola, and calculate the area in between. If you tried to do this using the x-axis, it would be much more difficult. And if you would like to try that, go ahead. But right now we're going to look at integrating with respect to y. You should get the same answer if you did it the other way. It's just a little bit more difficult. So remind me to show you this video. Let's review what is calculus. Remind me to show you that. Okay, so what we're going to do is take the integral of the right function, and these are both written with respect to y already. So the right function is the line, y plus 2. And then we're going to subtract y squared, which is the function on the left. So we're going right to left. We're going to integrate this with respect to y and go from a to b. Now we've got to figure out what a and b are. And again, we're going to set our two x's equal to each other, x equals x, and set y squared equal to y plus 2. Again, if you move the y plus 2 to the left-hand side of the equation, you get this equals 0. You factor y minus 2, y plus 1 equals 0. You find out that our function is actually going from y equals negative 1 to y equals 2. So that's what the a and the b will be. A is negative 1, b is negative 2. And those are the y values. Okay? All right, so let's continue on with our integration then as we change our a and b to negative 1 and 2. Okay, this is an antiderivative that we can do. And we should get the area equal to 4.5. And this takes into account that the area underneath the x-axis is negative and the area above is positive. So, and we can actually take the antiderivative, I won't do this whole thing, but 1/2 y squared plus 2y minus y cubed over 3, or 1/3 y cubed. And we take that going from negative 1 to 2. So the antiderivative at 2 minus the antiderivative at negative 1 should be equal to 4.5, and that's the area underneath that curve. All right, the second example, and last example we're going to do is page 395, number 24. And again, these are both set equal to x, but you need to actually graph these to check and see whether it's easier to do this using x or y. Because sometimes you will have a choice and you need to decide. Now, these two functions are written such that they're pretty easily written. X equals something. So we may want to go ahead and try it using the integration with respect to y. Now, these two graphs look like this. One, they're both sideways parabolas. One looks like that. The other looks like this. And so what we will actually need to figure out is what are these 2 points, because they're going to be our A and our B. And we're going to take the antiderivative from the right function, which is 3 minus 2y squared, and then subtract the left-hand function, which is just y squared. Now, one thing you might want to do before you do all this integration is simplify the inside there a little bit. Now, if you set these two equations equal to each other, y squared equals 3 minus 2y squared. We could add 2y squared to both sides. And we get 3y squared over here equals 3. Divide by both sides by 3, you get y squared equals 1. So y could equal 1 or negative 1, right? If we took the square root of 1. So A must equal negative 1 and B must equal positive 1. So negative 1 to 1. That is going to give us our limits of our integration. And now we just have to do the work. Okay, the hard part's kind of done. So again, I would take this and simplify it. 3 minus 2y squared minus another y squared is 3 minus 3y squareds. You could even, before you take the antiderivative, pull out that 3 and put it in front. Remember, if you have a multiplier, and then you would have 1 minus y squared dy. Pull out a 3. That just makes your math a little bit easier. You can multiply everything by 3 at the end. So your antiderivative would be y minus 1/3 y cubed. Multiply that whole baby by 3 and evaluate it between negative 1 and 1. Your answer, when you do that, it better be 4. So check it out and make sure you can get the right answer. That's it for 7.2 day 2. Happy integrating.